Hey everyone, I'm back and talking about bond energy or bond enthalpies still. We're on page 15 of the lecture outline, continuing our ideas from before. We're interested now in a carbon-carbon double bond. So we're going to use this very simple molecule. I think this is the simplest molecule we can find that has a carbon-carbon double bond in it. Okay? That is called ethene. Now, we need to write our equation for the enthalpy of formation. Okay? That is going to be 2 carbon graphite plus 2 H2 gas to give us C2H4 gas. Delta H naught formation is given in the problem as 52.47 kilojoules per mole. Okay, now I need to blow this up. I need to break these 4 carbon to hydrogen bonds and the carbon to carbon double bond. So what have I got going here? C2H4 gas is going to give us 2 carbon graphite and 2 H2 gas, and my delta H is now negative 52.47 kilojoules per mole. I can get rid of the graphites the same way I just did in the previous problem. Okay, 2 carbon graphite to 2 carbon gas, the delta H naught is 718.38 kilojoules per mole, and I'm multiplying by the 2 moles. Then I've got the 1/2 H2 gas gives me H gas at 217.94 kilojoules per mole. And to make everything balance, I'm going to have to multiply that by 4. I multiply this value by 4. 4 times 1/2 is 2, so the 2 H2s cancel, the 2 carbon graphites cancel, and I am going to be left with C2H4 gas gives me 2 carbon gas and 4 H gas, delta H naught for that reaction. When I added it up, I got 2254. So I need to look here. What am I breaking? I'm breaking 4 carbon hydrogens, so subtract 4 times 416. And that's going to leave me with 592, which will be the carbon-carbon double. And that actually makes sense to me, because that should be stronger than a carbon-carbon single. And back here on the previous page, for a carbon-carbon single, we got 333. I don't say that it needs to be double. That's not really accurate, but it needs to be more. So it went up almost double. I'm happy with that. Okay. For the carbon-carbon triple, we'll use acetylene or ethine, depending upon your age, C2H2. I'll write my heat of formation equation: 2 carbon graphite plus an H2 gas gives me C2H2 gas, and the delta H naught was this provided number, 227 kilojoules. So I'll reverse it. C2H2 gas gives me 2 carbon graphite and H2 gas. The delta H is a negative 227 kilojoules. I'll get rid of the graphites the same way I did before. Carbon graphite to carbon gas multiplied by 2. And my 718.38 kilojoules multiplied by 2. And then my 1/2 H2 gas to H gas multiplied by 2, and my 217.94 kilojoules multiplied by 2. All right, that's going to cancel. That's going to cancel. And I get my delta H naught kaboom. gas, and that is going to be a total of 1646. Notice these are all coming out to be positive, which they should, because it is energy going in. Subtract 2 times the 416, which are these two carbon to hydrogen bonds, and I get an 814 kilojoules. Pretty strong bond, and that makes sense. Okay, now we're getting to a more complicated molecule. Carbon, double bond oxygen, H to H. So I can find that carbon-oxygen double bond. Now the heat of formation was given, so carbon graphite plus H2 gas plus 1/2 O2 gas yields, sorry, messing that up a little bit. I wrote it as HCOH. There we go. Delta H naught is -116 kilojoules per mole. Okay. So I'm going to reverse that. And by the way, that formaldehyde is in the gas phase, just so you know. We're already there. So HCOH gas giving you carbon graphite plus an H2 plus an 1/2 O2. Delta H naught is going to now be positive 116 kilojoules per mole. I'll get rid of that carbon graphite the same way I've been doing. Delta H naught is a 718.38 kilojoules. I'll get rid of the hydrogen pretty much the same way. 1/2 H2 gas to H gas. I'm going to have to multiply that by 2. Delta H naught was 217.94 kilojoules, which I'm going to multiply by 2. Okay, but I've still got this oxygen. Luckily, that equation there is provided. 1/2 O2 gas gives me O gas, and that value is 247.5 kilojoules. This is part of why I made such a strong emphasis on writing heats of formation equations previously. Okay, those will cancel that. The graphite will cancel that. The 1/2 O2 gases cancel that. And I get HCOH gas gives me carbon gas plus 2 H gas plus O gas. And when I added that whole thing up, I got 1518 kilojoules. Now, I'm also breaking 2 carbon to hydrogen bonds, so minus 2 times 416 kilojoules, and that bond comes out to be 686 kilojoules, which makes sense because a carbon-oxygen double bond is pretty strong. Okay, that's page 15. Pause if necessary. Go back, look through each of the questions. And when we come back, we'll be working on the next page and a slightly different approach to this.